Welcome to section 9.4, Probabilities of Various Permutations. At the end of this section, you should be able to answer these questions. What is the defining characteristic of a permutation? What are some key words that indicate permutations? How do you calculate permutations of a limited number of objects from a set manually? How do you calculate permutations of a limited number of objects from a set with your calculator? What is a factorial, and what is its mathematical notation or symbol? What is the mathematical formula for calculating permutations? Well, first let's define what a permutation is. A permutation of a set of objects is an arrangement in a definite order of some or all of the elements in that set. So, order matters with a permutation. Here's an example. In how many different ways could you arrange 3 books on a shelf if you had 7 books from which to choose? We have 3 books out of 7. If I have 3 slots to fill, if I look at the first slot, I could put any one of the 7 books in that first slot. So I have 7 possibilities. And then I have a second slot, and since I've already used one of my books, I only have 6 choices for the second slot. Following the same logic, I would only have 5 choices for the third. So since all of these things are happening together, we're in an AND situation, so we multiply 7 times 6 times 5, which gives us 210 possible ways to arrange the 3 books. Here's an example where we have some additional restrictions in the situation. A permutation is selected at random from letters in the word sequoia. What is the probability that it has Q in the 4th position and ends with a vowel? Here we're asking about probability, so we need to remember that the definition of the probability of an event happening is the number of ways the event can happen over the number of events, possible outcomes in the sample space. So let's look at our sample space. If we had no restrictions, then I'd have 7 choices for the first slot, 6 for the second, 5 for the third, 4 for the fourth, 3 for the fifth, 2 for the sixth, and 1 left over for the last slot. Now, if we look at our restricted situation, to figure out the number of possibilities, I always start with the most restrictive possibility. And here, that would mean that we have Q in the 4th position. Now, having Q in the 4th position, there's only one way that can happen for the 4th position. I only have one choice for the 4th position. Our next restriction is that we have a vowel at the end. So in this last slot, I have a choice of all the vowels in the word sequoia. So there are 5 vowels in the word sequoia. And the rest of my slots are unrestricted. So I've used 2 of my letters, which means that I have 5 more choices for the first slot, then 4, then 3, then 2, and then 1. So my probability would be the product of all these numbers in the numerator over the product of all these numbers in the denominator. If I look at this, I can see I can do some canceling out to simplify my fraction. The 5s cancel out, the 4s, the 3s, the 2s, and of course the 1s, leaving me with 5 possibilities on the top divided by 7 times 6, or 42. You'll notice that in my numerator, initially, to fill the 7 slots out of 7 choices, I ended up with 7 times 6 times 5 times 4 times 3 times 2 times 1. That situation where we multiply all the integers from 1 up to a certain value has a certain name, or a specific name. We call that a factorial, and we symbolize that situation with an exclamation point. So n factorial would be the product of all the numbers between 1 all the way up to n. We could also think about it as working our way down from n to 1. Now 0 factorial is defined to be equal to 1. One reason you can think of to justify this definition is we saw in our example that 7 factorial described all the possible outcomes of ordering 7 objects. If we think of all the possible outcomes or ways to order 0 objects, well, there's really only one way to order 0 objects. Now, this idea of choosing a subset of objects out of a larger set and figuring out how many ways we could arrange this subset in particular orders, a permutation, is something we do quite frequently, and it just so happens that technology, in the form of our calculator, has the ability to do this for us. Let's say I want to find the number of ways to group 4 objects out of 7. Well, I pull out my calculator and I start with the 7 objects I'm working with in my set. Then I go into the math menu and I work my way over to the PRB, which is short for probability. And you'll notice that this second option here, number 2, NPR, the P stands for permutation. So I'll select the permutation. And then I will say how many objects I'm using out of the 7. So in this case, 4. And if I hit enter, I get 840. And that's how our permutation option works. You'll also notice in the math probability menu, option 4 here, the exclamation point or the factorial symbol. So if I wanted to use that and I wanted to know what 5 factorial is, that would be 5 times 4 times 3 times 2 times 1. So I could just go in and ask for 5 factorial. You might try doing this in your head before you actually see what happens on the screen. 120. Now we found that 7 P4 from our calculator was equal to 840. Let's figure out how we arrived at that number. We think we're choosing 4 objects out of a possible 7. So my first choice, for my first slot, I have 7 choices, then 6, then 5, then 4. So I get 20 times 6 is 120, times 7 gives me 840. So what is a nice, succinct way to figure out that that's what we have to do? Well, you'll notice that we have the beginnings of a factorial here. If I extended with the final 3 slots, 3, 2, 1, then I would have 7 factorial. But I don't. I only have up to 4. So I need to figure out a way to get rid of those last 3 slots. So if I divided by those last 3 slots, then I could talk about this calculation in terms of factorials. You'll see that this fraction here is 7 factorial over 3 factorial. Well, the 7 factorial, the 7 comes from the number of items in my original set. The 3 factorial is the items that I'm not choosing out of the 7. So that 3 factorial, here's my original set as the numerator, and my denominator is the not chosen portion of my set. So one way to calculate if we use the values from our original situation, the original would be n. If you looked in our calculator, it was NPR. So n factorial, and to figure out what's not chosen, we could take the set minus what we actually chose. So n minus r would give me the leftovers, and we take the factorial of that. So the algebraic calculation for a permutation of a selected subset from a larger set is this formula here. N factorial, which is the number of items in the set, divided by n minus r factorial, the number of items that weren't chosen to be included in the permutation. So let's recap. What is the defining characteristic of a permutation? Well, it's the point that order matters in the arrangement. What are some key words that indicate permutations? Things like and or in a row. How do you calculate permutations of a limited number of objects from a set manually? Well, laying out the number of slots, as we did in the first example, and working our way through the slots as our choices become more limited. How do you calculate permutations of a limited number of objects from a set with your calculator? We go into the Math menu, go over to the Probability area, and use the NPR option. What is a factorial, and what is its mathematical notation or symbol? A factorial is the product of all the numbers from 1 to a certain number, and its mathematical notation is an exclamation point. What is the mathematical formula for calculating permutations? Well, the formula is n factorial over n minus r factorial, where n stands for the number of objects in the set, and r stands for the number of selected objects from that set.